Today we started looking at the rules of exponents, and it's really important that you understand the why behind the rule. Because when we put all of the rules together, sometimes it can be hard for people to keep them straight if they don't understand the why behind them. So as we look at discovering these rules, we're going to write them in expanded form. We're going to write them out the long way to help us see what those rules would be. So 2 to the third times 2 to the fifth. If I wanted to write 2 to the third, remember 2 would be the base, 3 is the exponent. 2 to the third means that 2 would be multiplied by itself 3 times. So if I were going to write problem A out the long way, 2 to the third is 2 times 2 times 2. We're going to multiply that by 2 to the fifth. I just use a bigger dot to separate those two terms. And then if we look at this, I've just multiplied 2 by itself several times. And if we look at how many times, I've multiplied 2 by itself 8 times. So we could rewrite that as 2 to the 8th. Likewise, for B, if we were going to write it out the long way, x times x times x, that would be x cubed, times x to the fourth would be x times x times x times x. Then if I wanted to write that with the exponents, I'm multiplying x by itself 7 times. So that would be x to the 7th. For C, x to the third power, or x cubed, times x to the 6th. That would be x times x times x, times x to the 6th would be x times x times x times x times x times x. And then if we look at that, we're multiplying x by itself 9 times, so that would be x to the 9th. If we consider what's happening each time, if I look at the problem I started with and the answer I ended with, in class we noticed, oh, well, the base is staying the same, but my exponents, 3 plus 5 is 8. 4 plus 3 is 7. 3 plus 6 is 9. This is rule number 1. When we are multiplying the same base, we add our exponent. And then remember, the base stays the same. It makes sense to add them because we're really just creating a long string of those bases. So for A, we had 3 2's, and then we tacked on 5 more, so we had a total of 8. So if I were going to write the rule algebraically, x to the power of A times x to the power of B, that would be x to the power of a plus b. We would add those exponents. So what does that look like? For example 1, we have negative 3x squared y to the 5th times 6x to the 8th y to the 4th. We can use the commutative and the associative properties to rearrange this multiplication, right? This is negative 3 times x squared times y to the 5th times 6 times x to the 8th times y to the 4th. Every operation is multiplication. So we're going to rearrange those. Negative 3 times 6, we're going to put our coefficients together, times x squared times x to the 8th, times y to the 5th times y to the 4th. So we've clumped those coefficients, x and y. And now we simplify. So negative 3 times 6, those are just plain integers, so we're going to use our multiplication rules that we've been using. Negative 3 times 6 is negative 18. And then we have x squared times x to the 8th. So based on what we just said, we keep our exponent the same. We add our exponents. 2 plus 8 would give me 10, so I would have x to the 10th. And same thing for our y's. The base stays the same. We add our exponents. So we would get y to the 9th. So our final answer, negative 18, x to the 10th, y to the 9th. So in example 2, if we rearrange, we would have 2 times 8 times x to the 4th times x to the 4th times y to the 10th times y to the 12th times z to the 13th times z to the 4th. And then we start simplifying. So 2 times 8, 16. X to the 4th times x to the 4th. We keep our base the same. We add our exponents, so we would get x to the 8th. For our y's, same thing, keep our base the same. Add our exponents, so we get y to the 22nd. And same thing for our z's. Keep our base the same, add our exponents, we get z to the 17th. So our final answer, 16 x to the 8th, y to the 22nd, z to the 17th. So pause the video and take a look at number 3. Give it a try, and when you've finished, you can hit play and check your answer. Okay, so if we rearrange this, we have -4 times -3 times x to the 10th times x to the 3rd times y to the 7th times y to the 5th times z to the 6th times z to the 4th. So then if we simplify, -4 times -3 is 12. X to the 10th times x to the 3rd would give us x to the 13th. Y to the 7th times y to the 5th will give us y to the 12th. And z to the 6th times z to the 4th would give us z to the 10th. So final answer, 12x to the 13th, y to the 12th, and z to the 10th. So when we're multiplying the same base, we're multiplying the coefficients, and then for the variables, when we're multiplying that same base, we're adding the exponent. So that's multiplying. Rule 2, we're going to look at what happens when we are dividing. So again, we're going to write it in expanded form. 2 to the 5th would be 2 times 2 times 2 times 2 times 2. Over 2 cubed would be 2 times 2 times 2. And then we can think about, remember that fraction bar is division. So I can look at 2 divided by 2. That is 1. 2 divided by 2 is 1. 2 divided by 2 is 1. So now in my numerator, I have a base of 2. I'm multiplying it by itself 2 times. So we get 2 raised to the 2nd power. In my denominator, I now have 1 times 1 times 1, which is 1. 2 squared over 1, we could just write as 2 squared. Now, we're going to look at that in regards to what's really happening with our exponents. But if the problem said simplify, we would want to go ahead and simplify 2 squared and write 4. Likewise, for b, if we were going to write it out the long way, x times x times x times x times x over x times x times x. Again, we can divide. X divided by x is 1. X divided by x is 1. X divided by x is 1. So in my numerator, I have x squared left. In my denominator, I have 1 times 1 times 1, which is just 1. And then we would write that as x squared. For c, if we were to write c out the long way, I have x to the 4th in the numerator. I have x to the 8th in the denominator. And if I start dividing the x's, x divided by x is 1, 1, 1, 1. So in my numerator, I now have 1 times 1 times 1 times 1, which is 1. In the denominator, I have x to the 4th. And 1 over x to the 4th would be my final answer. Now note, I have to have the 1 in the numerator, right? 1/2 is not the same as just writing 2. Right? We can't just leave off the 1 if it's in the numerator. So you have to leave it as 1 over x to the 4th. And then for d, if we write it out the long way, we have x times x times x over x times x times x times x times x. If we divide, x divided by x is 1, 1, 1. And so in my numerator, I now have 1 times 1 times 1, which is 1. In my denominator, I'm left with x squared, so my final answer would be 1 over x squared. So in class, we took a few minutes to consider the problem that we started with and what we ended up with. And we thought about what was happening with our exponents, what was happening to the bases, what was happening to the exponents. So you might want to pause and think about that for a minute, and then you can restart the video. So in class, we noticed that when we're dividing the same base, we are actually subtracting the exponents. We also notice that the base stays the same. That's important. For example, on A, One of the most common wrong answers that I see, people would divide 2 divided by 2 is 1, and 5 minus 3 is 2. So they'll give me 1 to the second. But notice when we wrote it out the long way, it was the 2 that we had for the repeated multiplication. So important, important, important to note that the base stays the same. So for our rule, if we were going to write that, we could write x raised to the power of a minus b, because we're subtracting the exponents. However, x didn't always end up in the numerator. Sometimes x was in the denominator. So we took a few minutes to look at when our x would be in the numerator, when it would end up in the numerator, and when it would end up in the denominator. And what we noticed was that the part of the fraction that had the largest exponent would be where our leftover x's were. So for example, in b, 5 is bigger than 3. So when we write it out the long way, we would have 5 in the top, 3 in the bottom, and after we do our division, the leftovers would be on top because that's where the most x's were written out. If the exponent in the numerator is larger, then that base is going to end up in the numerator. But if the exponent in the denominator was larger, like on C and D, then that base was going to end up in the denominator because that's where the leftovers were. So we could write x to the power of a minus b, or if b is bigger than a, then we could think about it. We know there's going to be a 1 in the numerator, and then we would have x to the power of b minus a in the denominator. That would be another way to think about it. So let's look at some examples. For example 4, we have 6x to the 12th, y to the 5th, over 10x to the 4th, y to the 10th. So the first thing that we're going to look at are these coefficients. So just like with multiplication, we rearranged things to help us simplify a little bit better. We're going to use the same kind of thought process here. So we're going to start with 6/10. And 6/10 is a fraction. We want to reduce the fraction. 6 and 10 both have a common factor of 2. So we could divide them both by 2, and we get 3/5. So you don't want to write a decimal here. You want to write a simplified fraction. So we have a 3 in the numerator and a 5 in the denominator. And then we're going to get our x's. I have x to the 12th over x to the 4th. If I were going to write it out the long way, I would have the most x's in the numerator. So my x is going to end up in the numerator because 12 is bigger than 4. And then when we're dividing the same base, we're subtracting our exponents. So 12 minus 4 is 8. And then for our y's, I have y to the 5th over y to the 10th. So if I'm thinking about where y ends up, there would be more y's in the denominator if I wrote it out the long way. So it's going to end up in the denominator because 10 is bigger than 5. So my base stays the same. I subtract my exponents. 10 minus 5 is 5. So my final answer, 3x to the 8th over 5y to the 5th. So for example 5, we have negative 12, x to the 6th, y to the 3rd, z to the 8th, over 20, x to the 4th, y to the 12th, z to the 4th. So we're going to look at the coefficients first, and we're going to simplify negative 12 over 20. Some people in class divided them both by 2, so we would get negative 6 over 10, but then we wouldn't be finished simplifying. We can continue to simplify. We could again divide them both by 2, and we get negative 3/5. Some people recognize from the beginning that they could divide by 4. The important part is that you completely simplify your fractions. So here we're going to have a negative 3 in the numerator and a 5 in the denominator. And then if we look at our x's, the largest exponent is in the numerator. So our x is going to end up in the numerator. And then our base is the same. We subtract our exponents. 6 minus 4 is 2. Then for our y's, we have y to the 3rd over y to the 12th. Right? The biggest exponent is in the denominator, so y is going to end up in the denominator. We subtract our exponents. 12 minus 3 is 9. And then for our last one, we have our z's. So we have z to the 8th over z to the 4th. Our exponent is in the numerator, so z is going to end up in the numerator, and 8 minus 4 is 4. So our final answer, negative 3x squared z to the 4th over 5y to the 9th. Pause the video here and try example 6 for yourself, and then you can restart the video to check your answer. All right, so for example 6, we're going to start with 4 over 20, and if we simplify 4 over 20, we get 1/5. So in our fraction, we know we're going to have a 5 in the denominator. When we're simplifying, if nothing else ends up in the numerator, we definitely need to put the 1. So some of you guys might put the 1 and then erase it later if anything else ends up in the numerator, or you could wait until the end to see if there's a need to put the 1 or not, right? So if we look at our x's, x is going to end up in the denominator because 4 is bigger than 2, and then if we subtract our exponents, we get 2. And then if we look at our y's, we have y to the 3rd over y to the 12th. Y is also going to end up in the denominator. And then if we subtract our exponents, 12 minus 3 is 9. So in this case, nothing else ended up in the numerator. We have to put that 1. So 1 over 5x squared y to the 9th for our final answer. The notes from today's class are on Power Learning if you need to take a look. And if you have any questions, as always, make sure you're asking. Thanks.